Hey everyone, welcome to my channel. Today we'll be learning about CI/CD with AWS EKS. It's a very exciting session and it will be totally hands-on session. But before that, let's get with the introduction and some theoretical points. Then we'll be starting with the practical part. Okay. So first, these are the contents we'll be covering in this entire session. Okay. Now, what is AWS EKS? Now, AWS EKS or Amazon Elastic Kubernetes Service makes it easier to deploy, manage, and scale containerized application using Kubernetes on AWS. So, it's kind of Kubernetes that you are normally used to configure in some other servers or the kind of normal instances, but here it will be managed one. Okay, Amazon EKS run the Kubernetes management infrastructure for you across multiple AWS ability zones to eliminate a single point of failure. Amazon EKS is certified Kubernetes conformant, so you can use existing tooling and plugin from your partners and other Kubernetes community. Application running on any standard Kubernetes environments are fully compatible and can be easily migrated to AWS EKS. That's why it's so popular. Amazon EKS is generally available to all AWS customers. Okay, so some point that need to be noted. What is EKS? Now it's a managed Kubernetes service. It's run upstream case, not an AWS fork, which means actual Kubernetes cluster to be running. Use kubectl and its friends. That is kubectl and ecosystem or whatever plugins and everything available. It will be all applicable here. ECS cheaper than EKS for small. Now, if you're thinking about should you run ECS or EKS, you have to think about the current infrastructure, the workload, and everything. But it's good point to note that ECS will be cheaper if you want to run some containerized workload. EKS is closely integrated with AWS with other AWS services, but this is changing rapidly. KES is more popular than ECS or Elastic Beanstalk. Yes, this is also well-known factor that Kubernetes is most popular than the ECS or Elastic Beanstalk. KES run all major cloud providers and on premises. 60% of the KES deployments run on AWS EKS. That is 60% of the Kubernetes deployments run on AWS, and that's a very good fact. EKS secure by default. EKS Optimize API. So if you are wondering what kind of instances will be running, so it's AWS supplied AMI based Amazon Linux 2 will be running, pre-configured with Docker, kubelet, aws-iam-authenticator, easy to use a data bootstrap script, allow automatic joining of EKS cluster, build with backup. Next, benefits: no control plane to manage, secure by default. It's conformant and compatible with all Kubernetes plugins and everything. Optimized for code, built with the community. Oh, the cost part. Now the cost part. So AWS EKS cluster cost you 0.10 dollar per hour, which is $73 per month approximately. That is, if you run any workload in cluster or not doesn't matter. If you're running a single cluster of this this AWS EKS, you have to pay this mandatory. Now that's just the running cost of this EKS cluster. If you have like any EC2 instances, I mean you must have EC2 instances of course, and US volumes and other things, then that will cost separately. Okay, make sure you mind making this mind. Okay, it's very important part. So these are the companies that are currently running all this EKS. Now let's start with the actual hands-on. I mean that's what you guys are waiting for, right? So we'll be running the actual hands-on now. If you are if you want to get all this code and everything, all code is available in this particular repository. Okay, and inside that particular repository is EKS CI/CD folder. So in case you may not, if you want to keep up with the tutorial or you want to try it yourself, you're all welcome to utilize this repository and run everything. Okay, now the like what are the tools need to be installed in a local system in order to run EKS. Okay, or start the deployment of the EKS. So these are the tools need to be installed. AWS CLI. So you need to have AWS CLI installed. I will AWS CLI installed. Let's see. Now you have version 1 and version 2. I will highly recommend utilizing the version 2 based on your operating system. Install the AWS CLI version 2. Then install the Kubernetes that kubectl command line utility. Now if you're Mac OS, follow the instruction. If you're Linux user, follow this instruction, and if you're Windows, follow these instructions. Okay. You have to install the IAM authenticator. Just follow the simple commands and you will be able to, like, again, use whatever OS you have. Based on that, select and follow the instructions. Okay, you will be able to install. And the final part is install eksctl. That will be like, we will be highly utilizing eksctl to create the cluster. Okay, and then we'll configure everything else by the kubectl command. So very important, install this eksctl command, CLI tool to, it will be required for the cluster creation. You can see installation here also. Okay, if you run this command, you will be able to install the eksctl command for you in your machine. Okay, now next step is creating the cluster, and it's very easy. Let me show you. First, let me show you the cluster config file. Inside that EKS CICD, you'll see cluster.yml file. Here we are mentioning the API version, kind is cluster config. Some metadata I'm storing here. I'm calling it CICD demo, and the node group is here. So cluster name will be here, CICD demo. Make sure of that. Okay, and the region is US West 2. That's also very important. The node groups, inside node groups, we are saying the name is ng1, the name of the node group. Instance type is T2 medium. Again, this is something that I'm utilizing for your use case. It might be something different, might be high level, and that is fine. But at least I think T2 medium is required. Less than that, we will face some kind of issues. Okay, desired capacity 3. Okay, now, so what command we'll be using? We'll be running eksctl create cluster -f, then the cluster.yml. Okay, let's do run that part. So go inside the project after pull the codes from the GitHub. Then go inside the EKS CICD folder and run this command. Just copy paste from this document. The document URL will be available in the description field, in the description section, and as well as in the first comment. So make sure to download the file. Okay, we'll see the cluster getting created. It will take a few minutes. Wait for that. After it's done, we'll be running the rest of the commands. Let me explain how to make the Docker build, and as well as how to push that image into ECR. Okay, let's do that. Just the next part, building the Docker image. So we'll keep it running in this tab, and we'll get another tab here. Okay, let's make it bigger. Okay, this is to save time, guys. Now this is to save the time. We'll go to code deploy demo. Clear. Hope you can see it. I will make it a little bit more bigger. So now here's the Docker file already given here. Let me show the Docker file and explain a little bit more what it is. So this is the Docker file. So in Docker file, nothing special. Nothing is special here. Simply Node.js 14. Because I'm facing some rate limiting issue with the Docker Hub. So instead, I just push the Node.js image in my own repo. Now again, you can use your own repo in AWS ECR, or simply you can pull from the normal Docker Hub. It's up to you. Setting up the working directory here, copying the package file and installing all the dependencies, and then copying all the files, and then running the NodeJs application. Let's try to run the build in local first, and then see it's running fine or not. Okay, let's just follow the simple commands here. Now we'll be running docker image build -t, that is the tag. Then this is the name, that is the tag name of the image, and dot means the current directory. There is the current context directory of running the Docker builds. Okay, so let's do that. And so in a few seconds, it's completed. Now let's try to run it and see that if it's all working fine or not. In order to do that, we'll run docker run -d, that is detached mode, name, the CICD demo, then -p 3000, that is the port mapping we are doing. We are running host port 3000 and the container port 3000, then the image, then the tag name here. Okay, let's run it and see. Okay, so now go to your browser and try to check localhost 3000. Yes, our application working fine. And now we can push the image to the ECR. Okay, that's a very important part, because we want for the initial part we'll be doing using command line, but while doing CI/CD implementation, it will be all automatic. Okay, there will be nothing manual anymore. Now to do that, let's come back to the documentation, and here you'll see the publishing image to ECR. Now let's go to our AWS ECR page. If you log in into AWS, this is the default screen. Now search about ECR. You'll see Elastic Container Registry. Go there. And we'll be creating new repository. Let's call it cicd demo. Okay. Now go down, and there is a create repository, and click on the cicd demo. And if you click on the view push commands, you'll see all the commands available. Okay, so you don't have to think about what to run and where to run. Simply just follow these commands, and you will be able to push the image from your local to the Amazon ECR remote repository. Now let's run the first command, which actually doing the login, doing the ECR login and the Docker login access. Okay, let's do that. Let's clear the screen first and run the command. So we are running the Docker login first. It will take few seconds to log in. Okay, login succeeded. Now we need to build the image, that is docker build -t cicd demo, and done. Then we want to tag the Docker cicd, that is the latest build, with the remote repository latest tag. So let's do that. Done. Now let's push the image to Amazon AWS ECR. So as soon as you push the image, you will see that once it's done in the ECR, the image will be available. Let's do that. Copied it and running it. Okay, it will take few seconds, and then this image will get pushed to the Amazon ECR. So the image is now pushed. Let's verify it here. Close it and refresh. You'll see the image here. Okay, let us tag. Now this URI is very important here, because you have to copy the URI, and inside the ECS CI/CD you'll see deployment.yaml. You have to make sure that image section you put that entire thing here. Okay, and that's it. We come back here. Let's see if the cluster is ready. The cluster still in progress. Once the cluster creation is done, we'll be all good to start it. We'll start the deployment as soon as the cluster is ready. Okay, so now our EKS cluster CI/CD demo in West 2, US West 2 region is ready. We'll see after everything is done. We'll see at the end this message, whatever cluster name you specified and whatever region you specified is ready. Then that means that our EKS cluster is now ready. How to find it how it's ready and is ready to start work with? Just go AWS EKS, and we will find that the cluster is ready there. Just wait for a few seconds. Click on the clusters, and we'll see our cluster is now ready with the version 1.19. Okay, now go to EC2, and I will show you that let's go to the cluster config. 3 T2 medium instance should be also running at the same time. Yes, we have 3 T2 medium instances running, up and running. It's completely ready. And now the best part, we will be going to deploy our first application in the Kubernetes. Okay, so let's do that. And to that, we have two files. One is the deployment.yaml, and second one is the service.yml. Now the deployment.yml will run the pods, and the service.yml will run the load balancer. Now let's first look at the deployment. Here we're mentioning the API version here. The kind should be deployment. Okay, the metadata and level should be like this as mentioned here. Name will be the name of the deployment you are doing. and spec the replicas, how many replicas you want to run. Here I'm just running one. You might want to run it high number because the load is high. Match level, we are making sure the app and the app name match the levels so that it can the container can deploy it there. CI, the app the match level app name is CIC demo, and in the specs you will see the container name is CICD demo also, and the image here is the image you have pushed. Now let's apply these changes, and let's see how the deployment works. Let's clear the screen first. Okay, now let's go back to our documentation. We have to run Kubernetes apply -f, that is the file, deployment.yaml. Let's do that. It will take few seconds. Just wait for that. Okay, you will see if it's success, you will see deployment app CICD demo deployment created. And if you do kubectl get deployment, you will see the deployment status. If you want to keep watching, add a w command. It will be running in the watch mode. As soon as it get okay, you will see, you already see that, right? As soon as it get ready, you will see one by one. So how much is pending, how much is running, that kind of difference. And if you do kubectl get pods, you will see the running pod here. Okay, now we cannot access it. We have to add the load balancer here. That's why we are going to run kubectl apply -f service.yaml and see what it has. So in service.yaml, just simply we are specifying which app to target, that is CICD demo, and like which pod to target in more way. And type should be load balancer, and TCP you are targeting port 3000, that's the container port, and the traffic port will be port 80. Let's do that. Let's just copy from here. kubectl apply -f service.yaml. Okay, you'll see this service created. If you run kubectl get svc, we have the URL here. Let's wait for a few seconds. After that, it will be available. The load balance is up now. You'll see the load balancer showing the CICD app version 1. Now, here one case you should check that. Suppose this is a deployment, okay, and you just updated an image. Let's say we are making some change here in the index.js. Let's say CIC app version 2, and we just simply go to ECR, this elastic content registry, go to CIC demo. If you click on view push command, okay, so here let's make the build, then tag the image and push the image. It will take few seconds. Means it's already pushed, only the newly added part will get pushed. Okay, now, but if you see here, it doesn't get updated, of course, because it's not automated right now. We'll be making it automated, but at this moment it's not automated. And what if we do, let's go to cd q EKS cd q ctl apply --f and then deployment. You will see, they will see it's unchanged, and still it's running app version 1. It's not version 2, but the image is updated. Now how to update the changes? Actually, we have to run a command for that. And let's see our Buildspec EKS. I'll be coming here in more brief, but let's run a command first. We'll be running this command, kubectl rollout restart. That will just restart it, so the latest change will get pulled in the pod. Let's do. So just run the command. Okay, now if we do kubectl get deployment, it's already available and ready. And if we come here and do refresh, you'll see it's already version 2. Now it worked. Now I did this manually. Let's make it automatic using CI/CD. Okay. So to do that, let's follow the instruction first. Come here. We'll be using AWS CodePipeline, CodeBuild, and so CodeCommit and CodeBuild to achieve this. Now let's come here and go to AWS CodeCommit. Here already I'm hosting the repository code deploy demo, and this repository where we have all the files and every changes. Now let's make sure that we have all the changes just to make sure. Okay, some changes need to be added. Say new CI/CD changes, git push master, okay, the change is also pushed. Let's clear this command line. Now let's first, now we have the code commit. If you're not sure how to create the repository and on, you can see my past tutorial on creating the code commit repository and everything. You can go for that way. I assume you already know about code commit. We'll directly jump to AWS code pipeline. So we came to code pipeline. Now let's create a pipeline. Click on the create pipeline and it will give you this screen. Let's call it CI/CD demo pipeline. You can have at this end or not, it's up to you. We're just calling it CI/CD demo pipeline. And in the role, we are saying that AWS it's automatic generated. You can have your own also. It's up to you. Allow, so make sure that allow this this option should enable, because sometimes you need elevated privileges, and if you enable, then if whatever privilege is needed, it will be added in the role itself. Go to advanced settings, click on the custom location, because I don't want to create a new bucket for that. Here we have CI/CD. We have this folder AWS Sandip CI/CD demo. In this bucket, I'm storing all this demo, and we'll go with default AWS managed key for the encryption. Click on next. We have source provider. Now I'm storing the code in AWS CodeCommit repository. But if you, it's all same. If you have the code in GitHub, that's also fine. Doesn't matter. Here I'm just going with the AWS CodeCommit. The repository name is the code deploy demo. Branch name is master, and change direction option is AWS CloudWatch. So if you come here and see here, user pushing the code to CodeCommit, and then this Amazon CloudWatch will notify the pipeline, AWS CodePipeline. AWS CodePipeline make the build, like pulling the changes from the CodeCommit and make the build, and that the AWS CodeBuild will push the changes to the EKS. That's what it does. Okay, now go to the next, and it's a build provider. So in provider you have AWS EKS or Jenkins. We'll show using AWS CodeBuild. In the CodeBuild, you will see we have to create a new project. So click on the create project. Ask for the project name, so we can say CI/CD demo build project, and go down. You'll see all these options. If you want to restrict, you can enable it. Additional tags, again, it's up to you. Manage image, we'll go with the Amazon Linux 2. Let's make it a little bit bigger so it will be easy to understand. Amazon Linux 2. Runtime, we'll say standard. Image, we'll go with the latest image. Yes, environment time Linux. The privilege, enable this tag if you want to build Docker images or want your build to get elevated privileges. Yes, since we are going to make Docker builds, we need this to be enabled. Okay, this is very, very important. If you miss this one, your changes might not work. So make sure you enable that part. Okay. Role name is very, very important also. I will show why, but for the moment, let's go forward and I will show why it's very important. Timeout, quit timeout, certificates, redundant because you don't want any. 3 GB, 2 CPU, all good. All good. You can add environment variables here also, but it's better to manage in the pipeline because we are doing everything by pipeline, right? Now, very important part is buildspec.yaml file. In the commands here, you'll see I have mentioned buildspec.yml because normally your case you might not have multiple buildspec, but for my case, since I'm mainly doing it for the demo purpose, I have a lot of buildspec.yml file, right? That's why I have made a custom buildspec.yml, that's buildspec underscore EKS. So if it's not simple buildspec.yml, you have, and it's a custom name, you have to mention the full name or path here. Okay, so I'm just getting the full name or full path, you can say, relative to the root directory we have here. So then it will run whatever the command specified here, it will be running all this. Okay, now let's come here and continue to pipeline. So it will just create the AWS CodeBuild project, and it will be automatically attached here. Okay, now we need to add certain environment variables, and that's very important because otherwise your project will not work. Okay, so click on add environment variables, and the first command is and the first variable is AWS default region, and we can just get it from our URL itself, US West 2. The second one is cluster name. Again, that is also we can copy from the cluster name we have mentioned here in the EKS CICD folder, cluster configuration. It's CICD in cluster to YML CICD demo. And environment variables next is AWS account ID. Again, that is also easy to get. Just click on this and you'll see my account. This is the account ID. The next is the image repo name, and that you can get from go to ECR, that is Elastic Container Registry, and this is the repo name CICD demo, and next is the tag. Image tag here, we can call it latest. Okay, so we have all the environment variables required ready, and we can create the you should click on the next. And actually we don't want any deployment because your deployment is actually happening via the build stage itself, so we can just skip the deploy stage and skip. We are good. Let's skip the pipeline. So let's see. Oh, so pipeline got created, but you'll see it will fail in the build part itself. I will let you know why. But while it's happening, let's look at the build spec itself in a very detailed way. So we have this build spec underscore EKS file. If you see here, the version 0.2 run as root. In the installation phase, I'm installing some dependencies. There is first the kubectl. Okay, I'm installing that. Then after the kubectl configuration done, I'm running some regression check. Now what is in this pre-request check? If you come here to the EKS CICD, then pre-request.sh, here I'm checking we have kubectl or not, we have the aws-iam-authenticator already pre-installed or not. If not, I'm installing it, of course. If AWS CLI present or not, if eksctl present or not, and if cdx or Kubernetes. Now this is optional, but above are the very special one, and at the end you are seeing that AWS access is there or not. Okay, these are the important stuff. So in the build stage fail, if you click on details, if you can link to execution details, you'll see authentication error for sure. So yeah, first error itself, the access denied, because it doesn't have the access of the code itself. Since we got the error, we have to fix that error by adding or by creating a new role, or maybe adding access to existing, that you have to you. But I think it's better to create a fresh role and then add all the necessary access to do that. Now for you guys to help it out, I have created one shell script here where I'm creating the trust relation script, all the and attaching all the necessary policies. So just simply go to your command console and run sh. Then actually it's, if you are in the root directory, go to EKS ACD and then run sh. Then this create IAM role sh. Okay, if you run this script, you will see the role will get created. If you come to IAM, I've already done it, so I'll be not showing that. But if you just simply run it, it will create. If you go to IAM, you'll see under roles, the role name is CodeBuild kubectl role. If you come here and search for that, you'll see the role is created and is have all the access here. Okay, so you'll simply create that. Now if you see that particular EKS describe role, that is for the EKS access. Okay, now we have done that. Now once you've done that, you need to have this change, that is see, normally even if you have all the access required for the for the build role to interact with the EKS cluster, you still have to do some kind of mapping. So okay, here's the explanation from AWS. So when you create an Amazon EKS cluster, an IAM entity, user, or role such as validated user that create the cluster is automatically granted system master permission in the clusters. RBAC, that is role based control configuration. To grant additional IAM users or roles the ability to interact with your cluster, you must edit AWS auth config map within the Kubernetes. Now, if you're using the eksctl, like we used it to create the cluster, right? So you can just simply run the command. So if you come to the documentation here, you see you have to mention eksctl, then create IAM entity mapping cluster, then the cluster name. So here it's simply cicd, like I mentioned here, the cicd demo. There's a cluster name ARM. The newly created ARM will get from the console, or you can just get from here also. So if we come, so you can see IAM console here. This is the IAM role IAM. Simply copy that, and then you just simply you mention the username, which is the name of the role itself, and then in the group you see system master, so you're giving master level access. And if you do that, now the cluster have the access. If you're not using eksctl, you can simply just via this command you can get the AWS auth-YAML file in the local console. Just simply, if I do that, I've already done it. So if I do run this command inside here, you'll see the access automatically added since I run that command. So if you come here, you'll see the access already there added. I think this one, yeah, group the system master, so it's already added. But if you don't have the eksctl, you can just simply pull the file and then make some changes here, and just add the lines, and you can simply run kubectl apply -f auth.yml. Okay, that's all you have to do to add the mapping. And after you're done with that, you can just simply, let's say, go to the code, come to the code and say version 5, let's say. And now if we push the change, version 5 changes, origin master, you will see the latest changes will be applied. Let's follow that. So pushed. So if I go to the code pipeline again, you'll see is in progress. One more thing you should understand: if you you created the role, as soon as you create a role, you have to update the role in the code build. So how can you do that? Go to pipeline, then go to the CI/CD demo, that is a pipeline created. Then click on the code build, AWS code build option, and you will see, you will come here and then click on edit. Okay, in edit you will see environment. Go to the environment and click on the override image. Just go down make sure you have this flag enabled, because otherwise it will not run. And in the service role itself, just change the ARN from here. You will get the ARN here, right? Simply change the URL and update the environment. Okay, and it's all you have to do, and then it's all done. Let's come to the pipeline and see it's in progress. If you click on these details, you'll see I think it's mostly done. What phase, you can click on the phases to know what phases it's in right now. This pre-build phase is going. You can see it's a Docker working. The access also work perfectly. You can see here is if you call the service, it will give you the service URL, like service that is a load balancer URL. If you run that, you see right now is version 4. But as soon as the pipeline completes, you will see version change automatically. This already build is done and pushed and succeeded. Okay, so it's success. Now if you come to this and refresh the page, okay, it's updated to version 5. That's how it works. And it is very easy. You have all the things required. You have your EKS. Again, I will explain the EKS once again. Here what I'm doing, installing the Kubernetes dependencies, that is the kubectl, and since we are utilizing the Amazon own image, that's why we don't have to install everything, but I'm still adding some check in the request. This script you can see here to make sure that all the aws-iam-authenticator, kubectl, the AWS CLI and everything is installed. Just making sure. If you don't have, if suppose it missing something, it will automatically install. I have added the installation script as well. Let's come back to EKS, Buildspec EKS. Here then in the preview phase, again we are just logging into the like adding updating the configs, the kube config for that particular targeted cluster, and making sure the config working fine. And then we are making sure and then we are making sure the access working fine, calling the service. If it doesn't work, we'll see the error. In the ECR, we are just logging in and pulling the latest available image. In that way, the build time will get lower, since we already have the build image in the local when running the build. So in the build phase, we are just simply building the from the cache, the existing cache here, and then we are tagging with the local tag here. And then in next phase, when the build is done, we are tagging that local build image with the AWS remote repo, as you can see here. And then in the post build, we are simply pushing the image in the ECR, then making sure that we are applying the configuration. If some deployment config change happening is okay, otherwise it will be unchanged. And then you are restarting all the deployment. In this way, all the latest image changes will get reflected, just like here we are seeing the latest version of the app. Okay, I hope you find this is useful. And if you have any questions, you can ask me. Let's come. If you're done with the demo and everything, you can just simply delete the cluster in order to save cost, otherwise you get charged. In this page, I have mentioned all the additional resources which will be very useful for you if you want to explore more. I think that's all. I hope you enjoy the session. If you have any kind of question, any problem, simply let me know in the comments, and I will be answering as soon as possible. Okay. Thank you very much. Don't forget to subscribe the channel and share this video with others. Okay. Thank you. Thank you very much.